Hi, today we will introduce Apache IoTDB, a time series database for Internet of Things. A time series consists of a series ID and a set of data points, and a time series database will manage many time series like this. Time series data is the main data type in IoT scenarios, but in industrial IoT applications, we should also handle the following requirements. 1. Managing time series data and supporting advanced analysis on the edge side is trending, so the database should be lightweight enough, but it should also support big data in the cloud. 2. The database needs to handle the ingestion of tens of millions of time series data points per second stably. Third, compared with data center monitoring applications where the data is kept for a week or months, industrial users usually choose to keep all historical data for audit and statistical analysis of the whole life cycle of devices. 4. Queries on time series are diverse, like latest data query for monitoring, real-time downsampling for visualization and report, and all queries require low latency. 5. Though IoT scenario is write-intensive workload, we also want to support big data analysis without ETL. So, we developed Apache IoTDB. This is a system overview. We provide a data file API which allows the edge-side device generating IoTDB data files directly and then loading the files into the DB instance in the cloud or in the big data analysis systems. The edge device can also run IoTDB directly and synchronizes the data files to another IoTDB instance in the cloud. To support high compression and low latency query, we introduced TS file, a data file format for time series data. We use LCM-based mechanism to support high throughput ingestion and do some optimizations for faster data written, for handling out of order data, and for supporting updating data. For fast query, we take full advantages of summary info in the data file and proposed pizza and KV match indexes. IoTDB has integrated with many big data systems for relational SQL operation, big data analysis, interactive analysis, and visualization. Let's watch the video. First, you can download IoTDB here and just unzip the binary to run it. In our demo, we deployed a distance measuring sensor with a PLC and a gyroscope sensor. These sensors are attached on a Raspberry Pi, and they form a smart edge device. We use another Raspberry Pi to act as the cloud server. In our demo, the sensors generate time series data, and the data is saved locally first, and then the data files are synchronized to the cloud IoTDB instance. This is a timestamp we managed. There are 7 time series totally. By pull and push the sensor, the generated data changes. The frequency of each time series is about 10 Hz, but actually they are irregular. Using the last keyword, we can get the latest data points. This is a useful query for monitor. This is another query for raw data query. And this is a downsampling query. The time series data frequency is downsampled from 10 Hz to 1 Hz. And this is multiple time series outer join on the time series on the timestamp. We can call the operation as time series alignment. If there is no data at a given timestamp, we can use algorithm to fill the hole using fill keyword. Find similar patterns among the historical data. It is an experimental feature. All the above queries are run on the edge. Let's see the data files synchronization among the edge and the cloud. The top left is the number of files on the edge, and the top right is the number of files on the cloud. There's a gap. but the cloud is keeping catch up with the edge. And once the data is transferred to the cloud, we can query it immediately. Okay, let's see the integration with other systems. For visualization, we integrate IoTDB with Grafana. We can use Calcite to query IoTDB's data. In this way, we can use traditional relational SQL directly. Using Zeppelin, we can interactive operate the data. Using Spark and Hive, we do not need to transfer the data files to another file format like Parquet or others. Instead, we can do complete analysis by Spark SQL and HiveQL on IoTDB's TS file directly. Then, let's see the performance. We use a benchmark tool called IoTDB benchmark. The workload is writing 100 billion data points into 3 million time series. We deploy on an IoTDB instance on AWS, and we can see the write performance is about 54 million data points per second. IoTDB is an Apache incubating project now. We invite all who are interested in it to join the open source community to make it better. This is our mail list, the Jira address, and the website. Look forward to your contribution. Many thanks.